It's Thursday night. Welcome to the LAN Tamer stream. We're going to battle some IP routing stuff. Some basic IP routing, like PBR, policy-based routing. And we're going to be doing some Gre. So looking forward to that. This is review time here in the LAN Tamer stream. We're going back. We're between BGP and MPLS, and it's been a long day. I'm somewhat fried, but we got no time to complain about that. We got labbing to do, so let's get into it. We're going to do... I don't have much to talk about vlog-wise. I don't have much to talk about. No meat chunks to share. It has been that kind of day. It has just been constant, non-stop, even through lunch, work through lunch, that kind of thing. So anyway, here we are. We're taking time. We're carving out time to do what we got to do. So we're going to do some streaming now. And let me pull up the documents that we need here. We got a little chat window in case we get a little chitty chat. This, by the way, is a new game coming out. I will not be playing the game, but I've already started watching it pre-release on Twitch. Star Wars Battlefront 2, you can play as like... again, I'm not in any way affiliated or associated with it. It's not a promotion, but it's pretty cool to watch. Anyway, they got Kylo Ren, you got your stormtroopers, you can play as Yoda, all kind of stuff. It looks pretty cool. Anyway, that's our wallpaper of the day. This is our chat window of the day. In case anybody wants chitty chat, talk about networking, talk about your problems in the LAN, talk about wild beasts running around in the LAN, in the WAN, or whatever you want to talk about. That's cool. As long as it's networking related, we'll chat. We'll talk about it. I've already got topology loaded. This is the basic IP addressing. We're good to go. Disclaimer, as always, these labs I'm about to show you, at least my work on these labs that I'm about to show you is I'm working on the INE workbook. This is not labs of my design. If you want to do these labs yourself, definitely check out INE Incorporated's workbook, their video libraries, do the rack rentals, all that good stuff. I have purchased all that. Encourage you to do the same. Here we go. IP or policy routing. Yesterday we did IP SLA. We did some other stuff. And again, I'm between BGP and MPLS, going back doing a review sweep in weak areas. Trying to get faster, trying to understand anything we missed. That's what we're doing. So policy routing. These are our requirements for this lab. All right, so we want routes R4 and R6. Routes to R1's loopback. Just says R1's IPv4 address. Configure IPv4 default routes on R4. Ah. Okay. Default routes to router 1's Ethernet IP. Okay, got it. Know what you're talking about there. All right, so we're going to do R3 default route to R1's Ethernet. Roger that. Got it. Router 5. Default route pointing to R1's DM VPN. We're going to act like router 1 is on like a small network and just got a few routers, and router 1. Where's our map? Where's our map? So yeah, router 1. We got this shared segment. We got the DMVPN tunnel. We got a little network here. Maybe router 1's connect to the internet. All right. I can see that. In simple networkingcompany.com's network, maybe. All right. So then, what are we doing else? What else are we doing on router 3? Router 3, static route. For R5's loopback R5 static route to R3's loopback, I believe, through DMVPN. Through DMVPN. All right, pretty simple so far, easy to understand. Pretty basic stuff, right? Does it? You guys ever seen anyone using policy routing without static routing or dynamic routing protocols? I'd be curious. I don't think that's what this generally is used for, those scenarios, but hey, that's what we're going to do in the lab here. I would be curious if anyone has ever seen in production some routing at a site that is only using policy routing. Because we did that in a previous lab. We didn't even do static routes. We just did only policy routes. That may be part of what this lab is too. All right, configuring on router 1. We'll right along here in our requirements. So that traffic from R4 is routed through R3 over Ethernet link. And traffic from R6 is routed through R5 over DMVPN cloud. All right, so we got router 6 in here too. All right, so we got at least 5 routers. Okay, and in this, create 2 EACLs on our router 1 named from R4. Need more room here. Give me some space. Give me some space. And from R6. From R4 should match traffic sourced from R4's Ethernet. And from R6 should match traffic sourced from R6 Ethernet. This is where policy routing comes in, right? And then to verify, use Traceroute on R4, R6, or R3s, and no caps, R5, L0, 2. All right, so let's break this down. Let's pull up our map here. Policy routing. Let's get everything aligned here. Come on over here. Here we go. In fact, let's minimize you. Or not, go not full screen. All right, so here we go. Default routes on router 4 and router 6. We want a default route going here. Let's draw. Let's draw. Everything's better with pictures. So we got a default route here, default route here. Router 3 default route will be this way. Purple's default. Router 5's default route is this way. All right, router 3 is going to have a static route. Static route, technically default route is static route, right? No, don't do that. Static route to R5's loopback through the DMVPN. Okay, so we've got a route going this way. And then router 5 is a static route, also going this way. I'm not going to do the arrows. Then router 1 is going to have a policy that says traffic from router 4 to router 3 should go over the Ethernet link. Traffic from router 6 to router 1 or router 5 should go over the DMVPN cloud. Okay, so normally we might say, well, all I have to do, really, is I could put a static route here, right? Let's see, his default. Yeah, see, router 1 is not going to have any static routes, right? He'll have a static route. He'll have a static route. These guys have static routes. But how do we know where this one, traffic coming in this way, how do we know where it's supposed to go? This is going to be via PBR. So we're going to have one for this flow, and we're going to have one for this flow. And we're going to use ACLs. Okay, I think we got that. So let's do our config here. Now let's say, let's start with router 4. Let's start with easy stuff. And we're going to say IP route 0.0.0.0. And this is going to be 145.1.146.1. And same on router 6. Same command, right? Getting tight for space here. Okay, and then that takes care of that. Then router 3. Gonna have a route, also a default route, 151.13.1. Router 5, similar. Except this is going to be 155.1.0.1. Where did router 6 go? Crap. 3, 4. 5. Well, darn it. I erased that. It's okay. Gonna come down here. It's the same thing. All right, so it takes care of 3, 5. 3 is also going to have a static route. IP route 5.5.5.5. And that's going to be 2.5. Actually, we could say host here, right? IP route host. And the destination is going to be to the DMVPN. So next hop, 5.1.0.5. Okay. Then let's do the same with router 5, essentially. Three through the DMVPN. Okay, that's easy stuff. Now, policy routing, router 1. Mirror router 1. We are not going to have any static routes on you. And then there are a couple steps to this, I believe. So you create a, we have to create an access list, as it says here. Access list. We'll say, now this is where I had trouble first time. I actually have trouble sometimes on a router with the correct formatting of the access list. I've done so many access lists on the ASA that sometimes I carry over some of that into the routing into a router format. So this is really where I need to practice. So I think it's access list And I'm going to have to look at the router to be sure. Telnet viral 1000 access list. Because if I want to do by number, I just type 101, right? But here I need to do an IP access list extended. Yeah. And then I just do from R4 enter. Yeah. Okay. Then we match our statements. And this is going to be should match traffic sourced from R4's Ethernet. I don't know why we have to use extended here. But I think we can say permit IP host 155.1.146.4. Any. Yeah, I think that's what we want to do. So all we're trying to do is match from R4. So I need to put this in here, right? And then we need IP access list extended from R6, permit IP host 151.146.6. Any. Okay, then we do a route map. Route map PBR in permit 10, and we want to match IP address from R4, and then we want to set IP next hop. I think this is the right set command here. Well, where's this going? So if it's coming from R4, it should go to R3 over the Ethernet link. So set IP next hop would be 155.1.13.3. It would say route map PBR in permit 20 match IP address from R6. Set IP next hop 151.0.5. Yeah, router 6 to router 5 should go over the DMVPN cloud. Okay, then I think all we do is go to the interface where the traffic is coming in. So the interface GI0 146. And this is where I get a little sketchy here. Let's go and put this in. Make sure that syntax is okay. No. What's happening here? Configured terminal. Come on, guys. What's going on? There we go. All right, so it took all that. Likes it. He likes it. He likes it. Now we say, is it IP policy? Yes. Route map. Yes, we got it. We got it. PBR in. I think that's what we need on router 1. And again, it was IP policy route map PBR in. Okay, I can work on speed a little bit, I admit it, but if that's the right config, I'm feeling good anyway about the policy, or the conceptually. Know what I need to do here. And that's the major, that's the gist of this particular review cycle, is we're trying to just focus on concept. Conceptually, do I have this stuff down? On some of these labs, it's the third time I'm doing them. In fact, all these labs I'm doing right now, or in this cycle, is going to be the. Did I put the right one in there? How to have router 3 twice. I see what I did. Instead of adding a line, I copied the whole thing. Notepad's your friend in the lab. Come on, get this right. IP route, it didn't like that. IP route host. Okay, fine. We'll do the whole. Fine. See, I do have trouble with access lists sometimes. IP route 5.5.5.5, 205. All right. So router 3 is good. Router 4 I think is done. Yep. Router 5. Let's correct this. IP route 3.3.3. Okay, paste that in router 5. Get him going. Tell him that viral 10. Hello, router 5. Do what you're supposed to do. Booyah. All right. So what's our validation? Let's check our validation. Wouldn't it be great if everything just worked the first time? Wouldn't that be awesome? So we're going to go to router 4. We're going to do a trace route. Or let's see, this one is supposed to, for router 4, we care about getting to router 3. So let's do trace route to 155.1.13.1. Is that right? Yeah. Source 155.146.4. We get to router 1. Okay, just one hop, I guess. We have reachability. All right, cool. Do the same for router 6. Trace route. Let's see. Let me double check here. Traffic from router 6 is routed through router 5 or the DMVPN cloud. Okay. I'll bet it works for the trace route 155.1.0.5 source. Okay, I'm not sure why one had 2 hops and the other 3, but ping 151.0.5. So it goes this one. All right, so routing works. And we know that PBR is in use because a couple ways. Show IP policy. Will that work? I don't think that. Yeah. So we have to do show route map. All right, this says 0 matches. I'm not sure why. This definitely has some matches. Let's take the policy route out and make sure that that is actually what is happening. Show run interface GI 0, 1, 146, right? Yeah. I'm going to take that out. And now let's go back to router 4. Let's go back to router 6. Okay, it's still getting there. How is that possible? One 15105. Traceroute. Okay, let's look at router 1. Should be like very little information on here. Show IP route. Okay, this is directly connected. That looks right. So it looks like this routing will work either way. Let's see, traffic from router 6 to router 5 should go over the DMVPN cloud. Router 6 to router 5. Yes, and this has a route back. Traffic from router 4 to router 3. Let me just double check my requirements here. Traffic from router 4 is routed through router 3. Configure IP policy so that traffic from router 4 is routed through router 3. Oh, through router 3. Or the Ethernet link. And traffic from router 6 is routed through router 5 over the DMVPN cloud. Use Traceroute or the loopback addresses. Okay, that's what I missed. Traceroute to the loopback addresses. So this would be 5.5.5.5. Yeah, now it's going to drop. Yep, unreachable. That makes sense. Okay. We are back on track. Interface just 0.1.146 IP policy route. This is what I call it, PBRN. Now let's try it. See if I did that right. Show run route map. PBRN, that's right. So basically what we're saying is if we want to get to the loopbacks, yeah, if we want to get to the loopback, for example, with router 6, let me make sure you guys have not, maybe have a chat here. All right. So if router 6 wants to get to router 5, on a second. Yeah, so all traffic from router 4 should go this way. So that way it should be able to get to the loopback of router 3, right? Because router 1 doesn't have a route to the loopback. Right. So how's it going to get it there? Via policy routing, right? And let's see, this should be working now. It's not. I wonder why. Let's make sure, because router 6 is going to come this way. And it should go to router 5. It's going to set the IP next hop as this, which he has a route to. Now, can he get back? That's the question. He has a default route going this way, right? Let's make sure that's there. Let's make sure, oh, the source address, that's the problem. Source, interface. No. All right, let's check our configuration here. Router 1, show run route map. All right, it's matching packets here. Show run section route map. Ping 145.10.5, yes. All right, from R6, show access list. This one's not getting any matches. Have I done any from this guy? I think so. Let's see if we get any hits on that. Ping 3.3.3.3, source jazz 0, 1, 146. Also timeouts. And let's see if we get any hits. Okay, we're getting hits now, so that's good. Set IP next top 155. Yeah, ping. Okay, so we're missing something here. What am I missing? Router 5 should have a route to the Ethernet interface. 146.6, and he does. And router 6 has a route. Yeah, he can get there. Those are directly connected interfaces for router 1. Let's do Traceroute. Not that that's going to tell us much. Why is this going back to 1? Is this configured? Yeah, it is. So it goes to router 1, then it sends it to router 5. And then 5 is sending it back to 1. Show IP interface brief. I have the wrong loopback addresses. Duh, that's why. This was the loopback address for loopback 1 in another exercise. All right, let's clean that up. That would be why we're getting a circle here. Lessons learned 150.1.5.5. And then let's correct it on router 3. We're going to say, or 5, no IP route. I've been doing those other labs too long. Okay, router 3. And router 5. They're trying to get slick here. Trying to get slick. So now ping 150.1.5. Actually, it needs to go to 6 or 3.3. There we go. All right, we got it. Typo again. The curse of the typo. All right, I'm going to check the key. I think that's what we're supposed to do there. Yes, yes, yes. Set IP next top. Yep. All right. So at least we get the policy route. Man, the BGP has really helped me on the route maps and the use of the route maps and what you can set, what you can match. I've gotten much better at that. Okay, so we did this yesterday. What's today, the 9th? Yeah, today's the 9th. So that is the 8th. And this is the 9th. I'm not going to do that one. Gre Tunneling. All right, let's get to our GRE. This is going to be about practicing to the speed. And let me pull it up and see which topology we're supposed to use. Please be the same policy. I don't want to have to. Please be basic IP addressing. Yes, it is. All right. Viral, you're going to be happy tonight because I'm not going to throw any loops at you. Throw you for any loops. We just got to do some cleanup here in router 1. So let's say no here, no here. No route map this. No route map that. I had the craziest dream last night, guys. I had a dream that I woke up in the middle of the night and that I was back at one of my first IT jobs. And like someone who was low on the totem pole was now like the manager, and I was now working for them. It was so strange. It was like they wanted me to work on desktops, rolling out desktops. I was like, you got to be kidding me, man. I'm a CCNP. What are you talking about? Or am I getting paid enough here? What's going on? How do I get here? It was hilarious. It was funny in a way and not funny in another way. You know what I mean? So I was like, please don't let me ever regress so much in my career that I have to do desktop support again. Not that there's anything wrong with that. I think everybody should start out desktop support or on the help desk or something like that. I think that's great. There's nothing undignified about it. But, you know, I've put in my time. I've done my time, as they say, in that. I would not want to go backwards. Do that. To me, that would be going backwards. Unless, you know, it's either that and a Walmart greeter and I can barely tie my shoes, you know. Then, hey, desktop support, I'd probably be happy as a lark. Just don't make me lift up one of those big printers, or by then we probably won't print anymore. Yeah, that's a dream, right? Healthcare companies still fax. Healthcare companies still send out thousands upon thousands of faxes every day, some of them. So yeah, paper's going to be around a while. Paper's not going anywhere, people. Not going anywhere anytime fast. I don't care how many clouds you have. I'm just doing maintenance here, guys. I'm not just trying to take up your time talking smack. I'm actually doing work here. Filler. Doing filler. All right, we're back to square one. Ready for the next lab. Let's load it up. Let's go full screen here. And routers are cleaned up. Let's clean that up. Policy routing, you do not pose the challenge you once did. Sorry, buddy. Okay. This one is create a Gre tunnel. Let's tunnel, people. Let's build a tunnel. Create a tunnel between R1. Tunnel using IP addresses 151.130.x with a /24. Tunnel should be sourced from and destined to VLAN 13. Static routes R1 and R3 loopbacks use this tunnel. Verify with good old Traceroute. All right. So for me, it's going to be the terminology, right? Getting the terminology correct. Usually I build these labs, the DMVPN's already running, all the Jiri tunnels are running for me, you know. But granted, I need a little practice. And we've had some fun with Gre Tunnels here on the Land Tamer stream. Some of the regular viewers will tell you that we have done some weird stuff with tunnels just to see if it would work. So it's always fun playing with Gre Tunnels. Now let's just see if we can remember how to do it. Router 1. And I think we just do interface tunnel. What is this going to be? Do we have a tunnel already on that? We do. Show IV interface brief. Yeah, we get a tunnel 0. It's going to be a tunnel 1. Interface tunnel 1. Tunnel mode Gre IP. Can't remember if there's a hyphen there or a space. But we're going to do, let's see, shoot, I'm already getting stuck. Let's see, router 1 and router 3. We have to do IP address. Got to put our IP on there. 155.13.0.1, 255.255.250, tunnel source. Destined to VLAN 13. Okay, so that's right here. That's like, boom, boom. We're putting a tunnel right here. It's tunnel under. So this is going to be, I'm going to say tunnel source is 1.13.1, tunnel destination 1.5.13.0.3. Oops, excuse me. Sorry, Mike. All right. What else? I think that's it. Then we do, and we're going to be doing several tunnel. I think there's 4 labs here, but hopefully we'll just fly through these. Breezing through. IP route. What was the static route? To, okay. 1.5.1.0, 3.3. Here's where I can do a host, right? No, not here. On the access list. And the next hop is 1.5.1.13.1. No, sorry, 1.5.13.0.3 is the next hop. The tunnel IP. Okay, and then on router 3, we're going to take this same thing. Copy and paste. We love you. Copy, paste. Tunnel mode, and this is going to be .3, .3, .1, .1.1, .1. I think that's it. Man, if I get this right the first time that fast, I'm going to be happy. Nope. Interface T1, tunnel, space mode, Gre IP. You know, this lab is gonna get me with the age-old space or hyphen question. Is there a space or is there a hyphen? Jeez, man, that if I can only remember if there's a space or a hyphen for 48% of the commands, I would be in good shape, man. I would be in great shape. So I keep wanting to put hyphens where there are no hyphens. Why do I keep doing that? I love you, hyphen. You are one of the greatest punctuation marks that we have. I use you all the time in my emails, in my tweets. But you know, I think we may have to change our relationship here. We may have to look at our relationship again. All right, show interface. Cool. Tunnel 1 is up. Encapsulation tunnel. Can we ping can we ping the other end of the tunnel? 5.13.0.3. Is that it? No. Yes. 1.5.13.0.1. 1303. Okay, do I have the wrong destination? Show run interface T1. Seems like I'm missing something. That can't be right, can it? Does this have to be an interface? That's what it is. It has to be an interface, doesn't it? Interface T1. Tunnel destination. Yeah. No, it has to be IP address. Tunnel source, tunnel destination. You know, if I was in the lab, I would cheat. I would look at show IP interface brief. This is dynamic DMVPN though. Tunnel destination. Let me look at the doc real quick. What am I missing here, folks? This is under IP routing protocol independent. This is going to be GRE. Shoot. What is Gre Tunneling going to be under? I'm pretty sure it's under... Need to go a different product. Product support. Gonna say... No, that's probably right. Yeah, I was in the right place. Protocol independent. Tunnel. What would that be under then? Oh, interface and hardware component configuration guide. That's where it is. I should have remembered that. Implementing tunnels. Give me an example. Okay, so here's one. Router A, tunnel. Tunnel mode Jiri IP, tunnel source. They're putting the interface instead of the IP. That's fine. Tunnel destination, though. Is the physical interface. All right, so that's what I'm doing wrong. Got it? I got it. Tunnel source. GI0 or GI01 13. Same here. 0113 tunnel destination 5.1.13.1. 1.13.3. Okay, I think we got it. So we're going to do no interface T1. See if that does the trick. Yeah, I've got to practice this some more for sure. I got to have this down. I got to have this down without even thinking about it. So now ping 1513.0.3. Boom. Good. And if we do ping 155.1.0. 3.3. Did we do that static route correctly? 150, sorry. Yeah, I got the wrong. Yet again. $150. And same here. $150.1.1.1. All right. One more try. Hey man, we gotta be sharp. We gotta be just. Boom. All right. Let's clear this out. And we're gonna do another GRE. It may be the same exact tunnel in this next lab, but we're going to do it again anyway, just to get more practice. Already easy enough to tear down. Cool, cool. All right, now. Next GRE. This is Gre Tunneling and Recursive Routing. I remember this one being kind of tough. Hey, Litfire, how's it going there? How you doing this evening? Hope you're having a great Thursday. Hey, tomorrow's Friday, you know. Tomorrow is Friday. Let's see. Create a GRE tunnel. All right, this is Gre Tunneling and Recursive Routing. Yeah, this one gave me a little trouble last time. I do remember that. So, don't remember why. We'll find out. Router. All right, Gre Tunnel between router 3 and router 4. Oh, tunnel should be sourced and destined to these devices loopback 0 addresses. Yeah, this is interesting. This is, I remember this causing all sorts of problems. Then configure loopback 1 on router 3 and router 4, L1. $150.1.xx.x/32. Whoa, configure RIP V2 on router 1, router 3, and router 4. Enable on VLAN 13 and V146. Enable on the GRE tunnel. Advertise L0 and L1 prefixes of R3 and R4. Use Traceroute on R3 and R4 to verify connectivity between L1 networks of R3 and R4 through Gre Tunnel. Configure distribute list filtering to fix the recursive routing error. All right, I remember this. So this is a really sneaky one. This is like INE level sneaky, right? This is the, you know, INE is known for being sneaky, even sneakier than the labs. That's what I call it, tricksy. So this is one of these tricksy, like, screwed up. Why would anybody even, anyway. That being said, you know, you never know. Maybe this is based on real life TAC calls. I don't know. But here's what we got. So we got, let's break it down here on the map. So this is between router 3 and router 4, right? We're gonna have a tunnel. Let's do some pictures here. This is gonna be our tunnel, and we're gonna have RIP running. Let's do a big circle-y RIP cloud. Let's do this upright. Let's do. So that's RIP. And we're going to have RIP running on VLAN 13, VLAN 146. Let's getting that down a little bit. That's about right. That'll work. And we're going to enable RIP on the Gre tunnel. And that's where things get messy. Because, think about it. You're going to have... Where's my grabber? I want to grab this thing. What's going on? There we go. Jeez Louise. So we're going to have Jiri running on this thing, and Jiri and RIP, and we're going to be advertising the tunnel networks into the tunnel. All right, I'm tired of fooling out, so that's just going to have to suffice. There's RIP. Looks like a start of like a basketball or something. Anyway. I'll show you what I mean. So let's start building this. I'm just going to build this right in the router. All right. Right on the routers. So tunnel between router 3 and router 4. So let's do interface tunnel. Let's pull a config over here. Let's call it interface tunnel 34. IP address 15340.3 255.255.255.0. Tunnel mode Jiri IP. Tunnel source L0. Tunnel destination is going to be router 4's loopback, which is 150.1.4.4. All right, interesting. And that's all there is to that. Let's do the same with router 4. I don't think these tunnels will pass traffic this way. Yeah, we don't have RIP running, so we don't have connectivity to those tunnel destinations, right? Interface tunnel 34, IP address 15.34.0.4. And tunnel mode Jiri IP, tunnel source loopback 0, tunnel destination 0.150.1.3.3. Then we need to create a loopback 1. IP address 150.1.44.44 205.205.205.205. Same on router 3. (150.1.33.33 205.205.205.205). And we want to turn on RIP. Router RIP version 2. Network 155.1.13.0. network 151.146.0, and we want to advertise both. Now I'm just going to do let me think about this, where this error is going to come in. The error is going to come in excuse me, we're going to advertise loopback 0 and loopback 1. All right, let's just do it. Network, I forget all the levels of complexity of this, but network 150.1. Let's see, what is it? 3.3, network 150.1.33.33. Now, router 1 needs to be running, well, this is the thing. We're running RIP here, we're running RIP here. Yeah, we do want it on router 1. Okay, I want to make sure. Router RIP version 2, network 51.13.0, network 151.146.0. Okay, so now we should have RIP routes. Okay, we're doing a summary, right? 150.1.0.0/16. We need to do version 2. We need to do no auto summary, right? So clear IP route. Okay, now we're getting these specific RIP routes. So here we have 150.1.3.3. Yep, 150.1.33.3. Yes. Yeah, so I think what's going to happen is we've added this interface into RIP. We have these new loopbacks in RIP. What is up with preview today? Acting so weird. Okay, so we've got this loopback, we've got this loopback. And what we really want to happen is we want router 4 to form this tunnel to this loopback as the destination endpoint. But we don't want to advertise it through the tunnel. We want it to learn that route through router 1. So as soon as we configure this over in router 4, we're going to get the tunnel up and down. And what we need to do is create a distribute list so that RIP does not advertise this out through the tunnel interface. He still advertises it out to this interface, but we don't want to advertise that out of the tunnel interface. So we're going to need to do a distribute list to fix that. But you'll see the problem right now. We put on router 4. I'm going to say router RIP version 2, no auto summary. And we're going to say network 151.146.0, network 150.1.44.44, network 150.1.4.4. All right, boom, the tunnel goes up because now we have a route to 3.3. But I think you're going to see where it goes down. Show interface T1. There's a T0, yeah. Wait a second, what tunnel? I have not configured the tunnel yet, right? Show run. Right, show interface tunnel 34. Okay, this is up. Show IP route RIP. Ping 150.1.3.3. 33.33. Yep. Okay. Advertise L0 and L1 prefixes. Tunnel should be source and destined to those devices' L0 addresses. Use Traceroute to verify connectivity between L1 networks, loopback 1 networks of router 3 and router 4 through the Gre tunnel. Okay. Yeah, tunnel change state to up. Traceroute. Loopback 1 is 150.1.44.44. Source is tunnel 34. Interesting. Show interface T34. Hardware's tunnel encapsulation. Tunnel source. Tunnel destination. Tunnel 34 source tracking subblock associated with loopback 0. Two packets input. Okay, that worked. This is not supposed to work though. This is supposed to fail. All right, tunnel should be sourced from and destined to those loopbacks. Loopback 0 IPv4 addresses. Configure L1. 150.133. Yes. Did I do the right? Show run interface L1. Yeah, I did that correctly. Show interface L1. Yep. Configure RIP version 2 on router 1, 3, and 4. Enable it on the Gre tunnel. Did I do that? I think I'm missing that step. Show run interface T34. Aha, okay, that's what I didn't do. Router RIP network 1534.0.0. That's where we're going to get the problem. Router RIP network 155.34.0.0. All right, let's see if we get the error that I'm expecting. Show run interface tunnel 34. 34.3, 255.255.250, tunnel source, tunnel destination. As we can see, we should be able to ping the other side of the tunnel, but we are not. There it is, boom. Got it. Mid-chain parent maintenance for IP mid-chain out of tunnel 34. Looped chain attempting to stack. Always love that error message. Ah, one screenshot. Boom, got it. All right, so the way to fix this is this configure distribute list filtering to fix the recursive routing error. So what we want is to filter out we don't want to advertise. Let's see, what is causing the error? So we've enabled RIP on the tunnel interface, and it's sending the loopback 0 network through this, and that's what we want to filter out. So let's create a distribute route map. Delist out, permit 10 match, and we can do this. Actually, let's do a prefix list. And that's going to be, can we do a prefix list with RIP? I don't think we can. Maybe version 2, let's try it. And this is going to be 15.1.0.0 slash, is it 32? What is our loopback 0? Show run interface L0. Yeah, it is 32. So we're going to do a deny. Match IP address prefix list. Deny out. We're going to say route map delist out permit 20. And then we're going to say let's see, distribute list. Configure distribute list filtering to fix the recursive for the Gre Tunnel. Yes, studying for the CCIE routing and switching. So I'm doing INE labs from the INE workbook, and currently working on Gre Tunneling and recursive routing. So yeah, man, that's what this channel is all about, studying for CCIE, meeting up with other people who are also studying and want to collaborate. I think on this, I want to say, yeah, that's what I want to do. And then I want to say here, router RIP distribute list delist out interface tunnel 34. I think that's what we want here. Sure thing, Kinsell. Chime in anytime, man. Share your stories, share your battle scars. Feel free to give hints or ask questions. Interactive channel, my friend. You can follow me on Twitter also, and Instagram. Post a lot of stuff there at the Land Tamer, Facebook. Let's see. So this is going to go on both router 3 and router 4. I think this will work. Okay, router RIP distribute. Might be trying to get too fancy here with RIP. Delist. Oh yeah, out. T34. There we go. Yeah, don't send the tunnel destination and source networks out of that interface, please. That's what we want. So let's put that on router 4. Man, if I get this, that's going to be awesome. So what was the last message? Tunnel 34 temporarily disabled. Show interface T34. Okay. Tunnel is down. So let's see if it comes back up. And let's see if it stays up. And by gone, okay, interface change up and line protocol changed to up. That was a delay there, wasn't it? Usually it goes, nah, it's still unhappy. It's still unhappy. I think if I'm incorrect here, I believe this was a problem in the lab in viral, even though I had everything correct in the key. So I'm going to test that theory right now. And I'm going to look at the key and see if I have everything else correct, which I think I do. Distribute list, out tunnel 34. That's right. That's right. Okay, this did a little different. We'll try that. You know, I think my way works. But the key had it a little bit differently. What they did is it still used a prefix list, IP prefix list, or IP, yeah, prefix list, stop, recursive error, sequence 5 deny, 150.1.3.3. Oh, you know what? I had the wrong, darn it. I had the wrong, I'm gonna fix mine and see if that works. I'm going to say no, IP prefix clear. I've had so many typos tonight. I don't know what the deal is. Maybe I'm distracted. Just got so much on my mind. Not good. Okay, I think this will work. And then let's do the same on router 4, but we'll do this. Interface T34 shut. No shut. Fingers crossed. Interface changed to up. Now let's see if line protocol. And boom, mid-chain parent maintenance for IP mid-chain out of T34. Looped chain attempting to stack. So... and it goes down. All right. We will try it your way, Ione. We will try it your way. So their way was to do this, is say IP prefix list, stop recursive error. So we're going to take this out. Going to take this out. Take that out. Take that out. Let's just go and do that now. And the same over here. And we'll do it your way. Since my way apparently is not working. Then we do IP prefix list, stop, underscore recursive, underscore error, sequence 10, permit 0.0.0.0/0, LE32. Let me check the key, make sure, yep. All right, then they say router rip distribute list prefix stop recursive error out T34. You know, I tend to stick to, like, I know it might be a little extra work, but I tend to use route map, prefix list, route map, and reference to route map. And I don't think that's wrong here, except I did not have this. I don't know. We'll see. So we're going to do your terminal. And on router 3, we're going to do that. And on router 4, we're going to do this. Interface T34, shut. I'm just going to leave it down for a sec. We should still have a route, show IP route 150.1.3.3. We do. Redistributing, known via RIP. Always love the highly advanced routing metrics of RIP. Route metric is 2. Oh, if the world were only that simple. All right, so now we're going to say interface T34, no shut. And see what we got. Tunnel's changed up. And it looks like that is going to stick, so. If you don't have the 00 permit and explicit deny, it is, but you also have, in my route map, notice I had a permit 20. So, you know, had deny 10 match IP address, prefix list, deny out. And then I had a route map DLS out permit 20, which is an implicit permit in a route map anyway, I think. But obviously I was wrong because that did not work. But I have used this before as an implicit permit, permit all. But hey, like I said, that, and maybe that's related to RIP, protocol interpretation, because I'm pretty sure I've done this with BGP before. But again, that's BGP, and that's the most recent thing I worked on. But that is the right answer. So one sort of takeaway is don't try to get too fancy with RIP. Stick to a simpler configure, and this is definitely simpler, right? In terms of troubleshooting, like distribute list, prefix, single prefix list. Got one deny sequence and one permit sequence, which is all balls, right? Let's see. I think there's another one, GRE backup interface. And what else do I have on my list here? Okay, let's fill out our chart here. Let's fill out our fancy chart. Tunneling, recursive routing. Backup interface. I don't know if I'm going to do all this. I need to kind of move forward. This is taking a while. So far this week, so on Monday, I started reviewing the sections. And a couple days LAN switching, now a couple days, well actually like 3 days for LAN switching. I had to redo the private VLANs. Now I'm doing basic static, basic IP routing tonight. Yeah, we'll see. I'm doing a review for a reason, right? I'm doing a review to review, and this is important. But let's see here. Let's get him back, put him back to how he was. Now it lets me select them. And let's look at backup interface. I think this is really simple if I remember correctly. Shoot, I need to undo all this. What's the basic IP addressing, right? Show, run, brief. Let me clean this up. Not a whole lot to clean up here, really. I think just no interface T34, no router RIP. Yeah, let's just do that. No interface T34, no router RIP. Let's take out those other loopback interface too. No interface L. What was it? 34. No interface L1. Yeah. Okay, back to normal. On to the next one. Backup interface. All right, 2 Gre tunnels. Oh, between R4 and R5, 2 tunnels. T45, 5.45.0.x, VLAN 45. And then we have tunnel 100, 105.100.0.x, VLAN 100. The VLAN 100, I think they're talking about the, what are they talking about here? Tunnel interface, right. DMVPN. No, they're saying the VLAN 100. Let me check that. Last time I got this wrong. Okay, yeah, we want to use this. This has a weird IP scheme, but VLAN 100. Okay, static routes on, okay, R5. Static routes to L0 via T100 and T45. Tunnel 45 should have a higher administrative distance. We'll say 5. Configure the backup interface feature so that if tunnel 100 goes down, tunnel 45 is activated. Okay. Backup interfaces. If T100 drops, T45 is activated. Right, because T100 is going to be the primary path. The lower AD. Okay, we want to ensure backup link activates 3 seconds after main link fails. And deactivated when main link is active 60 seconds. Verify with Traceroutes and link shutdown. Okay. Shoot. What is the... Let's do our configs first. So router 4. We're going to say interface T45. IP address 1545.0.4 255.250 tunnel mode Jiri IP tunnel source J0145 tunnel destination 151.45.5. Okay, then interface T100. And what is this? Show IP interface. Yeah, it's this. I can never get used to that. So it's going to be IP address 15100.0.4. Tunnel mode, Jiri IP, tunnel source, interface 0100, tunnel destination. No, this is going to be 169.254.100.5. And then IP route to loopback 0 is 150.1.5.5. Next hop will be 1545.0.5. That's T45, AD of 5. Route 150.1.5.5. 5.100.0.5. Okay. Easy enough, right? I'm going to do the backup thing after all this configuration. So let's do router 5 is going to be very similar. So it's going to be IP address, it's going to be 5. This is going to be 4. This is going to be 5. This is going to be 4. This will be 4.4. 45.0.4. 0.4. Okay. Oh yeah. All right, let's put all this in. What did I miss? Tunnel source. Okay, when to use int and when not to use int. That is the question. When to use int and when not to use int. Telnet viral 1 to 0 10. Okay, tunnel should come up. Yep. Traceroute 50.1.4.4. Okay, it's going via VLAN 100. That's good. Show IP static route. And we've got the 2, right? Good deal. So that's correct. Now the backup interface part, I'm going to have to finger my way through it here. We want the backup interface. So we want T45 to be the backup interface. Backup interface. And this will be T100. Yes. Backup. Delay. 3. Backup delay 3. Wait a second. Backup delay. Seconds is 3. Okay. Ensure backup link activates. Backup. Configured interface as an active backup. Delays before backup line or down transitions. Yeah, we want the delay to be 3 seconds. What else does it want here? Let me look. Let's see, backup. This should be under interface and hardware component configuration guide. Yeah, I think it was under. Yeah, interface and hardware component configuration guide. Shoot. Okay. I'll bet I can find it if I do show interface T100. No, T45. Backup interface. Failure delay 0 second. Secondary disabled delay 0 second. Okay, so it wants kick in load not set. That's hilarious, guys. Hey, what's your kick in load set to? What's your kick in load set to, man? Backup, delay. We're gonna go 3 and 3. And then we're gonna say backup load thresholds. We don't want load thresholds. When main link is active for 60 seconds. What if we do that? So let's do backup, delay, 3 and 60. Then show interface T45. Backup interface, failure delay 3 seconds, secondary delay, disable, delay 60 seconds. I'm not sure if that's what that is. And I need to be able to find that. That is probably, okay, so let's go to, that's got to be under interface and hardware components. Let's go to the command reference. They just don't have, I guess they just don't have a configuration guide for that. So let's see, interface, iOS, yeah, it's under system management. Let's go to index. I mean, it should be under here. Okay, backup delay, backup interface, backup delay. Enable and disable period. All right. Number of seconds that elapse after primary before the activates. Number of seconds after it comes up. All right, simple enough. 3 and 60, that's what we want. All right, got it. So in the future, well, I think this one is set, right? That's a little misleading though. Secondary disabled delay. What the heck does secondary disabled delay? That is so confusing as to what that means. I don't even see how that wording fits into this scenario. If that's what the configuration guide says, this doesn't say secondary. Backup delay. It doesn't say secondary is nowhere in there. All right, I'm over it. So that's so misleading. So interface, let's see, show run interface T34, or what is it, 45, yeah. Not configured here? Okay, I've only configured it on. All right, so that's good to go. So now we need to do, I thought I did router 3. Oh, it's router 5. Duh. Show run interface T45. Okay, it's not here yet. Backup interface T100. Backup delay 360. Got it. All right. So now we should have a route. Show IP route 150.1.4.4. That would be a static distance of 5. Okay. That's correct. Or is it? show run. Okay, so take. It should be taking this route. Oh, this is down. That's why. Show run interface T100. I must have misconfigured something here. Ping 169.254.100.4. That's correct. IP address 155.100.0.5. Okay, let's look over here. Show run interface T100. It is down. .5, yeah. Show run interface T45. Do I have these backwards? I do. Okay. Configure the backup interface feature on R4 and R5 so that if T100 goes down, T45 is activated. So I need to come over, I need to take this off and show run interface T45. I don't configure this here, right? No backup delay 360, no backup interface T100. I need to tell T100 that his backup interface is T45, right? And that will shut down T45. Okay, interface T45. Can't chat at the moment. And we're going to say backup delay 360, backup interface T1. Wait a second. No. Got me distracted. Okay, I need to go to interface T100 and say your backup interface is T45. Backup delay 360. Yeah, that's what I need to do. Show run interface T100. Show run runt interface T45. Okay, yeah. I don't know what my CLI is doing right now, so backup interface T45, delay 3 and 60. Okay, now show IP route 150.1.4.4. Okay. We don't see an AD of 5 here, so it's using Tunnel 100. And T45 is changed to standby mode. And that's exactly what we want. Now, excuse me, now let's bring down this interface. Let's do a Traceroute. Good deal. It's going over Tunnel 100. So let's cause Tunnel 100 to fail. And the way we can do that is if we shut down 0.1.100 shut. And sometimes I notice in the virtual environment, you need to do it on both sides. All right, tunnel 0 goes down. Yes, we're not using that in this lab, but tunnel 100 should go down now. Boom, it goes down. Sweet. Now T45 goes up. Ping. That was quick too, you notice. We still have a route, and we do a trace route. Good deal. Okay, yeah, I got the concepts. Got to improve speed on this one. All right, let's bring the interfaces back up. And after a minute, we should see everything return to normal. Ping 150.1.4.4. Okay, we should see the tunnel come up again. A little delay. Wait a second. That should be 5.5. Actually, let's ping the other end of the tunnel interface. Okay, it's already up. Show IP route. Yep, it's no longer distance of 5, so good deal. All right, so that worked. That's great. I think the next lab is GRE reliable backup interface. Reliable, you can pretty much always read SLA, right? Although there is the GRE keep alives. That's right. So here's a keep alive statement. We can just do that here. Yeah, this is the same. Tunnel 100 should be determined through GRE keep alives. So all we have to do is say keep alive. And then there's a period of, yeah, we just do keep alive. And let's see if we see that here. If router 4's VLAN 100 interface is disabled, traffic should be rerouted. Okay, so let's try this again using the keep alives. Actually, I believe, if I remember this correctly, that you don't have to have it configured on both sides, but you inevitably are almost always going to want to configure it on both sides. Although it's not required, I do remember that. And generally, you want to have it running on both your tunnel. You would want to have it on both your tunnel interfaces, right? I remember this. We started to see a problem here on the keep alives in the DMVPN tunnel. Yeah, I remember this happening before as well. I'm not going to dig too deep into this one. Yeah, keep alive. There's some parameters that ask us to use 2, 1, and 3. But we still inevitably get this message for some reason on the DMVPN tunnel. Cool. I think that's going to do it for the IP routing portion. Thanks, folks, for tuning in, for chatting it up, and I will see you back now. As far as my stream schedule goes, as most of you know, if you're regular viewers of the channel, I'm here generally Monday through Thursday evening, generally between like 7 and 9 p.m. Eastern for 1 to 2 hours. I do that pretty regularly. You see that in my video list. Then I usually take off Friday night and part of the day Saturday. I usually do a lab or 2 Saturday, and then Sunday I do several labs, right? Here on the stream, live, uncut, unfiltered. Now, this weekend, though, is going to be a little different because I have a vacation coming up, and I've got family and things, so I'm probably not going to be streaming much until late next week. So it's probably going to be about another week before I'm back here. Feel free to, but I will be probably on Twitter and Instagram and sharing some of these screenshots and maybe some flashcards, things like that. I'm still going to be studying here and there between like meals or, being in the car or whatever. So anyway, feel free to hang out, stop on by. Next week when I'm back, and we will be back here grinding the CCIE routing switching labs, doing our reviews, and we're going to be moving on to RIP, I think is the next section. So we're doing some RIP and some EIGRP here coming up in the next week or two, just doing review. Thanks again, guys and gals, for all your support, and tune in to the channel. Please like if you enjoy this video, subscribe if you haven't already, and click the little alarm bell to see and be notified whenever I'm coming back live on stream. Take care, folks, and have a great rest of your weekend. We'll see you back here soon in the Land Tamer stream.